In this video, we will discuss Section 5 of the ASTM F3338, which covers the requirements in support of certification or approval. There are 26 different subsections covering everything from materials, operating limits, controls, vibration, stress, cooling, propeller tests, and more. As part of the certification requirements, the administrator must establish ratings and operating limitations. This information and any additional information are necessary for safe operation must be included in the product certificate datasheet. These limitations are found in Section 5.3.2. Some examples are maximum over torque and time, electrical power, voltage, current, maximum rated temperature, maximum and minimum continuous temperature, and vibration limits. Ratings found in Section 5.3.3 are based on the intended duty cycle and are defined by power, torque, speed, and time. There are a number of typical duty cycles used for electric motors. These can be found in IEC 60034-1. This IEC standard details multiple duties and their associated ratings for various operating conditions. The duty cycle can be described numerically using a time sequence graph or by selecting one of the typical duty times found in IEC 60034-1. An example of a rating is the motor rated output, which is the mechanical power available at the shaft and is expressed in watts. In some countries, mechanical power is expressed in horsepower. Other requirements for the design of the electric engine include overspeed of the electric engine rotor. The rotor must possess sufficient strength to burst above certified operational conditions and above failure conditions leading to rotor overspeed, meaning the rotor should not burst when subject to the analysis and test conditions in accordance with IEC 60349, Part 4. In addition, they should not exhibit a level of growth or damage that could lead to a hazardous electric engine effect. The max overspeed for rotors must be tested by running at multiple conditions, including those specified by IEC 60034-1 and in ASTM F3338, Section 5.9.3. The design of electric motors includes how to handle life-limited and critical parts. Critical parts are those parts where their failure could cause a hazardous effect, but the mechanisms are limited to high cycle fatigue or overload. As such, the part is not required to be removed by a certain number of flight cycles or engine operating hours. A propeller is an example of a critical part. Whereas life-limited critical parts have low cycle fatigue, creep, or other mechanisms and must be removed after accumulating a certain number of flight cycles or engine operating hours. These parts may be forced to be replaced during scheduled overhaul, such as bearings. Section 5.15.2 lays out the identification process for critical parts, and Section 5.15.3 for life-limited parts through defined processes or plans for engineering, manufacturing, and service management. Section 5.19 covers safety analysis. This process means the engine design and control system is analyzed to assess the likely consequences of all failures that can reasonably be expected to occur. This section includes references to other sections of the standard, such as 3.2.4, 5.15, and 5.19.4. The final requirement that this video discusses is Section 5.20, ingestion. For electric engines, the focus is on cooling blockage and structural damage. Cooling failures are defined as a blockage of the cooling passages due to bird strike, hail, or ice contamination. Any structural damage must not result in any hazardous electric engine effects.